Hello, namaste. Welcome back to the course on Geographic Information System. Today's we have in the previous this entire week we have spoke about what is a database, what are different types of database, query language. Then we have also looked at what are the two types of database management system languages. Then we looked at what is a database management system. Basically, we also looked at different types of database management. We looked at hierarchical database, we looked at relational database, object oriented databases. Now once we have looked at all of these, now we have learned what is a database and what are different database management systems and database system by default. So once you have learnt it, now you have data in the database. Now if you have to really query something or understand how best the data is and how best the data can be accessed or how fast the data can be accessed, for that you need certain ways of organizing your database. It is just like if your house has to look really neat and you have to access some of the things very fast, so you organize your house in such a way that certain things are easily accessible, or if you have one particular thing you can find out the other. So similarly in a database you will have to do certain kinds of probably manipulations in terms of normalization. That is what is called data normalization. We have learned this in our previous class. Today we would learn what are different normal forms. Okay, we have 5 different normal forms. We will look at it and how, if your data is normalized, how do you denormalize? You need it for certain operations when you have to do denormalizations or you are moving data out of a database. So now in this class, first we would look at certain concepts. First, as I said, we would look at normalization forms. We will look at first normal form, second normal form, third normal form. When we look at third normal form, we will also look at Boyce-Codd normal form or BCNF, and we will also look at fourth and fifth normal forms, though I have not listed it here. And finally we would also look at denormalization. Okay, so how do we get out of normalization and how we do a denormalization of data that is in the normal form. Now let us understand normal forms. Now when we look at normalization, as I said, is to put the data in order in a database in order to see how well your data can be organized, so that retrieval is fast, quicker, and you have efficiency in the database. Now when I say the data is in the first normal form, it means to say that each attribute data must be atomic. When I say atomic, it should not have multi-value, which means every attribute data cannot have 2 values at an instant. Okay, and it is not composite data. And once you have attained the first normal form, if you have to look at the second normal form, which means you have arranged your house in a particular order, so which means that only some of those are quite accessible, retrievable fast. But if you want to improve that, so next step is the second normal form. When I say second normal form, the main condition is that your database first should be in the first normal form. Once your database is in the first normal form, each key non-key attribute, so it is not about the key, it is all the non-key attributes must be dependent on the primary key. Now please understand the usage of primary key and a non-key here. Okay, so when I say primary key, it is an unique key which is uniquely identified in the entire database, correct. So now when I am looking at the second normal form, it is that it has to be in the first normal form, and any non-key attribute, which means which are those which are not considered as any kind of keys, whether it is primary key or whether it is secondary key or whether it is a foreign key. So none of these should be a non-key attribute, none of these forms. So it is a non-key attribute that must be dependent entirely on the primary key. Okay, so this is what means the second normal form. Now so once you have attained this second normal form, now you try to see that you attain the third normal form, which means you are trying to iterate it more so that your house looks more cleaner or more organized. Okay, so when I say third normal form, it is that the basic thing is it has to be in the second normal form, right, and each non-key, again it is the same non-key attribute that depends only on, here please look at it, here it is entirely on the primary key, but here it is only on the primary key, which means it can even depend on primary key plus any other key, but it has to be entirely dependent on primary key for its retrieval. But in the third normal form, it has to be dependent on the primary key only. Without dependency on the primary key, it cannot be got into the third normal form. Okay. So, this is about the third normal form. Now, the next stage is fourth normal form, which means extremely organized. Okay. So, now if you want to make it extremely organized, it means that you should have your data already in the third normal form for your fourth normal form, and there can be no more than one multi-valued attributes in the relation. Till here you did not have any of these three forms, we did not have any kind of multi-valued functions, but in the third normal form there can be no more than one multi-valued, which means any attributes can have only one multi-valued attribute in the relation. That is what is the fourth normal form. So, now we are in the stage where the first we cut down it, that you cannot have, and you should always have an atomic form. Now, once you have attained the atomic form, that is, it is not a multi-valued, then in the second normal form we use first normal form and a non-key attribute, okay, which is entirely dependent on the primary key. In the third normal form, we use a second normal form and a non-key attribute that is dependent only on the primary key, but when it is a fourth normal form, we have third normal form, there can be certain attribute values which are multi-valued in terms of its relation. So, it is only in terms of its relation. So, please understand this point. So, multi-valued in terms of its relation. The final thing is the fifth normal form. Fifth normal form again has to be in the fourth, if your data has to be fifth normal form, then the first thing is it satisfies the fourth normal form conditions, then table cannot be split into two or more tables without a loss of information. Okay. So, if you are trying to look at the fourth normal form, after fourth normal form, if there are many attributes which are multi-valued, okay, which means that there are more than one multi-valued attributes. So, you try to see that the loss you can duplicate into number of rather than duplicate, you can multiply into number of tables, but that multiplication of into tables will lead into certain loss of information in the fifth normal form. So, normally the fourth normal form is considered to be extensively best, okay, but the fifth normal form has certain issues in terms of loss of data. Okay. So, that is why it is normally not used. Now, when we are looking at when we are looking at the normal forms, the first thing that we have to understand is a concept of functional dependency. When I say, when I think about a value x is a value y is functionally dependent on x, which means you are trying to write that value y survives because of x. Here the value of x, it says if this arrow is positioning like this, it means to say that this particular variable is functionally dependent on this, or x functionally determines y. Okay. So, without x, y cannot be found out, that is exactly the meaning. Okay. So, y is functionally dependent on x. The arrow shows which variable is functionally dependent on which particular variable. So, now for each value of x in R, which means to say in that particular set, there is one associated y value always when it is functionally dependent. Okay. So, let us consider this as a particular set, which means x belongs to A, y also belongs to A. Okay. Now, if x belongs to A, okay, now if it has to be functionally dependent, it means say x and y. If you see here this value, this value, so y is functionally dependent on x, okay. But when you look at this, this particular value is 4 and this particular value is 2, you cannot have such dependency that exists for a single particular attribute. So, it is functionally not dependent on x, it cannot be determined, okay, basically. So, this is about functional dependency. So, once you have understood about functional dependency, let us look at normal forms. Now, what does first normal form says? The first normal form says the value should be atomic. So, what does atomic mean? Atomic basically means every column is unique. So, when you are looking at it, let us consider this particular example x, y, z. When you are looking at each of these columns, okay, x is 1, 3, 2, 1. Now, this particular column itself is not unique, okay. If we consider x as a primary key and z as a attribute data, so you both attribute data repeats and is not unique, okay. So, it is not in a first normal form, it is multi-valued function, okay. So, now if you look at the same table that has been put in the first normal form, the value is unique, it does not repeat. So, it is not a multi-valued nor composite function, here it is more of a composite function, okay. So, this is what is called a first normal form. How you translate, very simple example of a first normal form. Your database would be too huge, it will not be as simple as what I am showing here, but this is just an example of giving you an idea of what does first normal form mean. Now, again let me take another example. Here you have a customer order information, okay. When I am looking at a customer order information, there is an order date. Look at every details very carefully. You have an order date, these are 3 different order dates, all 3 order dates are independent, they are not on the same day, okay. So, you have a customer name. So, when you look at the customer name, you have the same name that is repeating, and when you look at it, even if this customer name we consider it as a primary key, if you look item as an attribute data it has to be, if you look at here, it is not atomic, each column is not unique, it has 2 different values, okay. Now, if this particular thing can be translate, if we want to try and translate this particular thing in the first normal form, it is as simple as this. I create a table with just a customer ID. So, this would be my primary key. In this case, I would create a customer ID and a customer name, okay. Now, this particular customer ID is linked to another table which has order ID, order date and the item. Now, you can see in any of these tables, no data is, all data are atomic. If you see here, bread, milk, coke, apples and bread. If you look at this, is if bread is for first, and if you look at this is for first customer, and if you look at milk is related to the first customer, coke is related to the first customer, apple is related to the first customer, and the quantity is related here, okay. So, most of these values are unique to this particular customer only, we do not have anything like milk, etc. So, this makes this particular database and first normal form, the one that is translated to the first normal form database, okay. So, I hope everyone has understood what is a first normal form. This is a very basic form of how database works, okay. So, if we are looking at the second normal form, I did tell you that it has to be in the first normal form first, which means it has to be atomic, okay. Now, and each non-key attribute must be dependent on the primary key. Now, I said let us take customer ID as a primary key. Now, we have all of these are non-key attributes, whether it is quantity, item or order date. When you are looking at, let us say, an bread is not completely dependent on the primary key here, okay, because it is determined by the quantity, it is determined also by the order ID. Okay. So, if a particular, for example, here now I am if I consider order ID as a primary key in this case. Okay. Now, what I do is that I break up into two different tables. So, I consider here order ID as a primary key. Okay. Again, order ID is here the primary key. Now, each item here is dependent on the primary key for its existence. This is a non-key attribute. There is no key associated with it. So, it is dependent on the primary key. Primary keys are 1 and 2. Okay. So, that gives you more information about the quantity. So, now if you have arranged it in the form of a primary key, you have arranged it in the form of a second normal form, even looking at atomic values, and all these values are atomic, there is no second value attached to any of the attributes that are linked here. So, it means it is atomic, and also non-key attributes are defined only by the are dependent entirely on the primary key, right. So, this means to say that this particular thing is in the second normal form. Now, if it has to be a third normal form, the entity should be considered already in the second normal form, which means you should already have the entire table in the second normal form, and no two columns entry should be dependent on any other entry other than the key for the table. Okay. So, if you understand it, other than the primary key for the table. So, when we look at this, if you are going by the mathematical relationship for every functional dependency of y with x. Okay. Now, when we are looking at this, it is functional dependency something like this. So, functional dependency of y to x. So, the first rule states that where y is in x, which means y is when you are looking at the subset, okay, y is a subset of x, or when you are looking at the rule number 2, when y is not the subset of x, okay, which means to say that these are two different rules, wherein if you have these two rules satisfied for a functional dependence of y towards x, then that particular table is in the third normal form, which means in the rule number 2, if x is a super key of R, if you are considering this set x is a super key of R, R is a relationship, the entity relationship value. So, if your R is considered to be the major set, and if you are trying to consider x is a super key of R, then y is a prime attribute, which means to say y dependent on x is contained in the candidate key. When I say candidate key, every attribute information can be a candidate key. Okay. So, y that belongs to x is contained in the candidate key for R. So, let me explain it in a more simpler way. So, if we are considering this example here, okay, let us say the first thing that we have to consider, it has to be in a second normal form. When we are looking at it here at this particular table, we can also see that every non-key attributes may not depend only on the primary key in this case. When you look at this particular order key, it very clearly says, the third normal form says that it has to be dependent only on the primary key. Okay. But when you see, this is one non-key attribute, this is one non-key attribute. When you are looking at here, price is dependent on the quantity, price is dependent on the quantity, again the price is dependent on the quantity. Now, which means to say that there is one non-key attribute which is dependent on the other and not directly on the primary key that we are trying to use. So, this means to say that this particular thing is not in the third normal form. So, how so what we would do, it's as simple as this. Again, first thing is see that whether it is in the second normal form. When I say second normal form, it has to be atomic, and most importantly it should be dependent on the primary key. Now, let us say, now I have broken down into two groups. When I am looking at third normal form, the same item ID is considered to be the primary key here. Okay. Now, I have the same primary keys here. Okay. First thing is it has to be atomic. Now, if you see, it is atomic, no value is repeated. The second thing is it has to be in dependent on the primary key. Now, everything is dependent only on the primary key. For example, number of quantity is dependent on item ID, quantity is again dependent on the item ID again. Okay. So, when you look at the item ID here, it says this is item description, its price is 3. Okay. So, it again this is dependent on the item ID. Okay. So, it is in the second normal form. Now, the third normal form, third normal form says it is only dependent on the primary key. Yes, it is only dependent on the primary key. Yes, both of these are only dependent and not dependent on anything else. So, now this table has been split into two and is in the third normal form. So, this is how we start with normal database: first normal form, the second normal form and the third normal form. So, please be careful the way you split up each of these three into different normal forms. Okay. And okay. So, now let us also look at what do we, okay, let us look at the next set wherein we will be discussing about the fourth normal form. Okay. Now, before we go into fourth normal form, we will also look at BCNF. As I said, is a Boyce-Codd normal form. When we are looking at a functional dependency, that is y being dependent on x, okay, it means when I have a rule y is in x and y is not in x, it means to say the subset of x are not in x. We would define in the second rule, we have already defined that x has to be a super key. This we have already seen previously. How? Let me give you an example of this. We have a customer schema or customer database. We have customer name, customer where he stays, which street and which city. Okay. Let us say that we are trying to look at the database of Amazon. So, Amazon may have huge number of customers all throughout, or Flipkart may have huge number of customers all throughout. So, now I have a customer name who has ordered on a Flipkart and his street or her street and the city, okay, where he or she stays. Now, which means to say that customer, as per this protocol, customer name is dependent on customer street and city, which is not in the BCNF because it does not satisfy the rule number 1, which means y is in x is not a subset of x. Okay, customer name is not a subset of x. Okay, but if you have something like this, for example, order ID of customer order, okay, customer street and customer city. Okay, what does it mean? Now, the order of a particular item is dependent on the street and city where it is being delivered. There are so many items which may not be delivered, right? So, this satisfies the rule number 1, which means say that y is in x, it is a subset of these functions. Okay. So, this is an example of being a Boyce-Codd normal form. Okay. Now, another example, very good example that can be taken is a loan schema. Okay. If you have a branch name, customer name, loan number and amount, this also cannot be an in the BCNF or in the third normalized form. Why? Basically, it does not satisfy both the rules. For example, the second rule, loan number cannot be any super key here. For example, what are you trying to define here? You are trying to define y, x, a super key 1 and a super key 2. Super key 2 can be an one example of where it can be used, but when you are looking at super key 1, which is a lone number, this particular lone number can be for both wife and husband. When the super key is for both wife and husband, it means to say that it is duplicating. So, if it is duplicating, your entire third normal form fails. Okay. So, this cannot be in the third normal form. If it was just a branch name, customer name and amount, then it could have been in a third normal form, because the branch name is dependent on I mean, if you look at y, rather than branch name, if I say amount is y, comma customer name, comma let us say some other attribute which is a super key of this. So, then it would have been in the second rule which would have been satisfied the rule number 2. Okay. So, that would be in the BCNF form. These are some examples that I am trying to tell you in the real life way how you put it in the normalized form. Okay. So, then there is in the fourth normal form, the basic thing is it has to be in the third normal form, and it can be one multi-valued dependency. When I say multi-valued dependency, for example, when with definition x, if x is represented something like this, then it is called multi-valued, one value, two value. So, it has a multi-valued function. X multi-determines y, y is multi-determined by or dependent on x. Okay. So, if x x or let us say if it is functionally y is functionally dependent on x, then x is multi-determined by y. Okay. So, determines y, sorry. So, when we are looking at this, if you have any legal relationship, all pair of tuples T1 and T2, if you have two tuples, two rows which are actually having a particular primary key and attribute data. So, if there are two tuples T1 and T2 in a particular relation, such that T1x is equal to T2x, there exist tuples 3 and 4 such that, okay, if you look at this particular thing, I am trying to explain this, T1x equal to T2x equal to T3x equal to T4x, if we consider something like this, because it is a multi-valued function. T1y is equivalent to the T3y and T2y is equivalent to T4y. T1 of r minus y, the superset, is equivalent to T4 of the r minus y, which is again a superset. Okay. This is what is called a multi-valued dependency. Okay. If you go back and try to understand how this dependency is developed, you will be able to understand this particular normal form in more detail. That is a fourth normal form. For example, if I have some database like this, I have an employee ID which is 1, 2, 2, 3, 4, then I have a project. Okay. There is two different projects running. Okay. So, please mind here what does fourth normal form says. Fourth normal form says the first thing is it has to be in the third normal form. Okay. First of all, it is not in the third normal form, very clearly it can be seen, and no more than a multi-valued attribute in the relationship. Okay. No more than one multi-valued attribute, but it also states each attribute value must be atomic. When you see here, attribute value is not atomic. Fine. So, now the thing that we have to develop this into a fourth normal form. How we will do this? So, first we will develop the first subset of that particular table. We will develop another table which has only employee ID and the skill, which means to say that employee ID number 1 has a skill A, employee ID number 2 again has a skill A, 2 also has skill B, which means it is a multi-valued function here. Okay. And y is functionally dependent on x. Okay. Then employee ID 3 is again has a skill C. Okay. Now, the same employee ID is a primary key here. Now we are carrying forward the third normal form. So same employee ID which is the primary key here, each of this 1, 2, 3, 4 refers to skills, that is nothing but Visual Basic, SQL Server and this. So now it is indirectly relating to, yes. So now the same thing has to be related to the project. So use the employee ID here, okay. The same employee ID is now relating to the project, okay. So this is how you derive the fourth normal form, okay. So then the fifth normal form is a bit complicated. I would not really get into details of it, but if someone is really interested, please if you can understand what is projection joint dependency. So the concept of projection joint dependency is very important in terms to understand the fifth normal form. So what does it state is every joint dependency is implied by the candidate keys of R, that is every Ri, there is a set of Ri which is a super key for R. So there always exists a super key for R. That is what is the first thing of a fifth normal form. When you are looking at it, this example is basically giving you a fifth normal form. Only thing is that there is a loss of information when you are looking at the fifth normal form. So this is an example of a fifth normal form. You have employee ID, you have a project. Now the same project is giving you the skills, and each of these and the same employee ID is defining you the skills here. So they are interrelated. That is how your fifth normal form is developed. So if you want to do it, please look at PJD. So that would give you some information of or more information on how do you develop a fifth normal form, okay. So but I would suggest everyone learn that particular part, because in case you want to write an exam in GIS, fifth normal form can be extremely useful in terms of understanding, okay. So yeah, so this is again an example, so I will not get into that. Then there is OLTP, okay, this is same example that I have shown here, okay. Then the terms OLTP versus OLAP. So when I say OLTP, it is online transaction processing. So when you are trying to do a database normalization, in whether we have to look at it whether it is transactional, which is statically transactional, or online transactional processing. So in which data, when you say online transactional processing, data modification happens very rapidly and randomly throughout the database. That is called online transaction processing, okay. So if you are looking at something that where you are trying to analytically vary the entire database, then it is called online analytical processing, which means that data contains a large amount of denormalized and summarized data. So you are analytically processing that particular data for optimal performance and putting it in the form of a different normal forms in the database. Then it is called as online analytical processing, okay, or OLAP. So we have OLTP and OLAP. So when I say OLTP, it is transactional processing, and when you are saying it is when it is in the denormalized form, you are converting into certain ways of summarized data and trying to put it in normal one if possible or not. So you are trying to put it in the online analytical processing. That is a difference between OLTP and OLAP. I have just included this particular slide so that you understand the terms of OLTP and OLAP, but it is not necessary that it has to be used in terms of processing, okay. So the last thing that I would discuss here is the denormalization. When I say denormalization, now we have understood normalization, which means that we have a database that is generated, whatever the data is that is generated, then we have put it in such a certain form so that it is easily accessible, quickly understood, and retrieved very fast. So now denormalization means whatever you have done with the normalization, you are converting back into the data. That is what is denormalization. So it is the technique to move from a higher to lower normal forms of a database modeling in order to speed up the database access. Many a times the fourth normal form may or the fifth normal form may take a bit of higher time. Why? Because if it is it has lot of connections, then reaching the nth connection may take a bit of time, but not in today's computational context. Okay, when you are looking at this commonly used techniques in data warehouses to speed up the query processing. So, you try to denormalize it and do the query processing. Denormalization should be used mostly on static data as opposed to OLTP data. So, it is more on OLAP data itself. Okay. So, or it is more on static data rather than OLTP or OLAP data, it is more on static data. So, when we are looking at example of demoralization, this example can be taken into context. Now, if you have this is one example that I was showing in the first and the second normal forms. Okay, this is a normalized data, which means to say that, see, for example, this is atomic. Okay, this is atomic, and also it is in the second normal form, basically dependent on your primary key. Okay, now the same thing, if it is put it back in the same order. Okay, so it is atomic also. So, you have processed from the second normal form to the first normal form, which means you are denormalizing by one extent. So, that is what is called as a denormalization. You are getting back the entire database from second normalization form to third. Similarly, if you do it from third to second, then 2 steps. If you are doing from 4 to 1, then it is 3 steps denormalization. So, that is how denormalization works. Okay. So, in summary, we looked at normalization forms, the first, second, third, fourth, and I did not explain the fifth normal form, but I just gave you a brief overview of what is a fifth normal form. Then we looked at Boyce-Codd normal form for the third normal form aspect. Please look at the projection joint dependency. I have not spoken here because it itself is a topic that can be easily dealt for entire week. So, please look at projection joint dependency, which is also very which is extremely important if in case you are trying to understand the fifth normal form. Then we looked at denormalization. I gave an example of how you denormalize from a second normal form to the first normal form. Okay, any way you try to do it from any step to the any step. So, that is nothing but a denormalization. So, with this I would end this week's introduction to databases. So, in the next week we would look into more aspects including how do we query, what kind of query we can do, what kind of analysis we can do on the database, what are different analysis that we can do, and if we are looking at query languages, what are different query languages and how they are useful. So, this is what I would speak in the next entire module of the next week. So, that if you have understood databases, then querying is other part. So, both of this can be extremely useful in terms of if you are trying to become an advanced GIS user. So, until then, have a nice time. Thank you very much.